I built a CPU myself. And yes, some people actually do that, including me. And yes, it actually runs stuff. Continue. But running Doom, is that actually possible on a homemade CPU? The original Doom is ported to absolutely every platform. The reason why it is ported everywhere, it's because it's fun, and also because the code is pretty simple. So let's say you want to run Doom on your CPU. To do so, you don't even need to touch the code, and that is because Doom itself is simple C logic that runs and compiles on almost any target. The only thing you actually need to do is to specify how to use the input-outputs to display some stuff. But more on that later. My CPU, the Holy Core, is a RISC-V CPU. RISC-V is simply the instruction set that my CPU understands. It's kinda like x86 or ARM, except it's not the same. And that's more than enough to compile and run Doom, in theory of course. But running the actual game logic is only half of the story. Just because the CPU can compute a frame, it doesn't mean it knows how to display it. It has to know how to talk with the actual hardware of your platform, the screen, the keyboard, and the IOs, etc. Like, it will not guess where your screen is. There is a handful of front-end functions that are meant to interact with your input-outputs. And one of these front-end functions runs every time a frame has been computed. So this is where you take this and use it at your advantage. You can put any piece of code here, which means you can just say, hey, I want to display something on the screen here. And that's great, because I'm broke. So I don't have a screen, I have to buy one. To solve this problem, I can just display the frame that has been computed into a UART terminal. This allows me to visualize Doom as text on my main PC. So after some struggle to actually compile the code, fix the bugs, and get the UART things going, I got an actual Doom frame. Like, Doom is actually running on the CPU. It's shit, but it's a frame. But of course, I was not done yet. As you can see, the gameplay is not very gameplayable, I guess. The first problem, of course, was the lack of a screen. But in the meantime, while I was coding, the screen arrived in my mailbox. The second obvious problem is the time it took to compute one single frame. Right now, even though the screen updated instantly, which is not the case, we would have 0.27 FPS.
Hell no, man. What the fuck, man?
But I was able to use my wizard skills to actually understand what was going wrong. The CPU was waiting most of the time. But what was the CPU waiting for? CPU are simple, yet extremely fast calculators. That's all they do math. And memory is their best friend. They constantly have to talk to memory to fetch instructions to know what to do and to send and load data from the memory. But the problem is that the memory is slow. It is actually one of the slowest parts of a system. To talk with the memory, we need some signals, assertions, some state machine, and these takes time to move data in and out. A great solution people thought about a long time ago was to add caches to the CPU. But there is one small problem. We have to actually design the caches, which means I have to work. I actually already had a toy cache example from the previous video, but it was so bad that the core was 10 times slower with the cache. Therefore, I have to go back to work. I'm gonna skip over the details of how the cache works because it's f***ing boring. But you just have to know that it took me 1 week and a half of my own personal free time. Yes, I could have invested that time in better things, but once the data cache was running, oh boy, it was very fast. We can safely say that this shit was a huge win. And yes, I know what you're gonna say. The screen is so tiny, and the SPI is not refreshing fast, etc. Keep that in mind for later, this is important. For now, we'll just try to do better, alright? We got some FPS going, it's fun, but it's not fun enough. I want some optimal gaming experience going on this CPU. But now that we have a data cache, what easy leverage do we have left? Well, the first very obvious problem is that my CPU is not able to multiply. Doom relies heavily on multiplications, so this is a big problem. A first good performance boost was to add the M extension to the CPU, supporting the multiplication through hardware and not through some slow software routine. But something was still holding the CPU back. You see, the CPU don't only fetch data from the main memory, it also fetches instructions. Until now, I was lucky enough that my old cache system was performant on this task, because instructions run in a loop, which means fetching instructions like I was doing before is actually increasing performance. But we can do way better than the shitty ass cache. So it was time to throw out this old cache and recycle the data cache that I just made to completely boost instruction fetching performance. Now we can try it out, right? It's gonna be so fast, it's gonna be so great. I can't wait to use it. It doesn't fucking work. It doesn't work at all. It doesn't work. It never works first try. And remember this SPI screen shenanigans where the screen was so small, etc. Basically, the problem is that I didn't read the datasheet, leading to me not having a screen that works reliably. And it took me 3 weeks to realize that. So I corrected the bug, and now guess what? The SPI screen is so fast that I can do it full screen. And after some more tweaking, I got Doom to run on my own CPU. Look at all these colors. Look at this gameplay. 2 whole FPS, including the screen refresh. There you go. That's how you run Doom on your own CPU. Check out the links in the description. You will have the GitHub repo with all of the documents to reproduce this CPU by yourself. Hey, I hope you enjoyed this video. Don't forget to like and subscribe. It really helps the channel more than you think. If you have a question about the GitHub code or the video itself, don't hesitate to leave a comment down below. I'll read them all. Love you guys, and I'll see you in the next one.